Hello class, in this video I'll be showing you how to find the domain and range of a function given its graph. Let's begin. So in example 6 I have the graph of r of x. I'm going to start by finding the domain. And to do that I'm going to find the coordinate that is furthest to the left, and I'm going to start there. So in this case that is the coordinate -3, 2. And notice that the circle is open. So I'm going to place an open circle at -3, 0, and the graph travels to the right forever. The open circle implies that -3, 2 is not a coordinate on the graph of r of x. So that implies that -3 is just a lower bound for the domain. It's actually not part of the domain. So the domain here is going to be all x such that x is strictly greater than -3. All right, now for the range. For the range, I'm going to look at the lowest coordinate on the graph and go from there. So the lowest coordinate on the graph is 1, -2. This circle is filled in, so I'm going to put a closed circle at 0, -2. And this graph increases forever. All right, since the circle is closed, we can assume that the coordinate 1, -2 is indeed on the graph of this function. So that will imply that the range is y is greater than or equal to -2. All right, so now that we wrote the inequalities, let's go ahead and write the domain and range in set builder notation. For the domain, that is going to look like this. This is going to be all x such that x is real and x is strictly greater than -3. For the range, that is going to look like this. We have y such that y is real and y is greater than or equal to -2. All right, now for the interval notation. For the domain, the lower bound for the domain is -3. However, since -3 is not part of the domain, I'm going to start with a parenthesis and then write -3, and we're going to go to infinity. For the range, -2 is the lower bound, and -2 is included in the range. So I'm going to write a bracket before the -2, and since the function increases forever, that's going to be followed by an infinity symbol. And we are done.